All right, guys, so this is our exam 3 review that's going to cover the main concepts from everything from class this week. So let's start here with problem number 1, looking at our infusions that are going to be given by gravity. So our provider has ordered for our patient to receive 10 milligrams of Reglan and 50 milliliters of normal saline IV piggyback over the next 15 minutes. There are no pumps available in our facility, but we do have IV tubing with a drop factor of 60 drops per milliliter. And we want to know what the flow rate is going to be in drops per minute. So we see here we have available 10 milligrams of Reglan and 50 milliliters that we're going to give over 15 minutes. And we have a drop factor of 60. And we want to know what the flow rate is going to be in drops per minute. So now remember here, with these problems, there's only one exception that we're going to talk about later on, but as a general rule, we only care about our volume that we're giving. So in this case, 50 milliliters. This 10 milligrams is just how much medicine is in that volume of fluid. So we don't care about this. All we care about is our volume and the amount of time it's going over. So let's draw our dimensional analysis square. So available for what we have available here is going to be our 50 milliliters over 15 minutes. And remember, we're looking for an answer to be drops per minute. So think of this as I need drops on top and minutes on the bottom. So we're going to set our problem up. That's going to help us get that. So 50 milliliters over 15 minutes. Now what we have as our available is going to be our drop factor here. So we have 60 drops over 1 milliliter. So our milliliters cancel out and we're left with drops over minute, which is what we need. So we can multiply across the top and multiply across the bottom. So 50 times 60 divided by 15 is going to give us 3,000 divided by 15. Which is going to give us a total of 200 drops per minute. And remember, all of our answers for this week are going to be in whole numbers because remember, there's no way that you can look as your drops dropping into your drip chamber that be like, yep, that's 0.2 of a drop or that's half a drop. So we have to do everything as whole numbers for this week. All right, moving on to our next problem. Our patient or our doctor wants our patient to get 450 milliliters of normal saline over the next 3 hours. Again, we have no pumps, but we have a drop factor of 20 drops per milliliter. And we want what the flow rate is going to be in drops per minute. So draw our dimensional analysis square here. And again, this right here, 450 milliliters over 3 hours is going to be, what we put on the left as our order, and our drop factor's going to go on the right. So 20 drops per 1 milliliter. Milliliters are going to cancel out, and we're left with drops over hours. But my answer needs to be in drops over minutes. So now you should ask yourself, how am I going to get hours to minutes? Well, we know that in 1 hour, there's 60 minutes. So we're going to draw a third column and pop that into here. So our hours cross out, and now we're left with drops over minute, which is what I need, so I can go ahead and multiply across the top and the bottom. 9,000 divided by 180. Which is going to give me 50 drops per minute. All right, so now moving on to our problems that have to do with giving infusions on an IV pump. Here, our provider wants our patient who's NPO to get 1,500 milliliters of D5 over 14 hours. And we want to know what the flow rate is in milliliters per hour. So draw our dimensional analysis cross. Remember, our order goes on the left, so 1,500 milliliters over 14 hours. Okay, so that's all we have from our problem. And we have milliliters over hours, which is what our answer needs to be in. So all we're going to have to do here is just divide the top by the bottom, which is going to give us 7.14 and continue on. But that's going to round to 107 milliliters an hour. All right, so looking at the next problem, our patient needs to get 2 units of blood over 45 minutes. Each unit is 250 milliliters, and we want to know what our flow rate is in milliliters per hour. So if you're going to give 2 units, and they're each 250, we're going to give a total of 500 milliliters over 45 minutes. So let's take that, which is going to be our order, and we're going to plug that in on the left. Okay, there's nothing else I have for my problem, but unlike the one before, I have milliliters over minutes, but I need milliliters per hour. We'll think back, I know 1 hour, 60 minutes. So we're going to plug our 60 minutes up here, pop our 1 hour down here. Our minutes are going to cross out, and now we have milliliters over hours, which is what we need, so we can multiply across the top and the bottom. So 500 times 60 divided by 45. It's going to give us 667 milliliters an hour as our answer. All right, continuing on. Now our patient needs to get 40 milliequivalents of potassium chloride in 250 milliliters of normal saline. We have a policy that states that the medicine must be infused at a rate of 15 milliequivalents an hour, and we want to know what our flow rate is in milliliters per hour. So this is the one exception to that rule of where we don't care how much medicine is in our volume of fluid. So if your problem says that your facility has a policy, or that the pharmacy states or recommends that a medication is infused at a rate of blank, that's the only time we care about how much medicine is going to be in our volume of fluid. So let's set this up. We have our cross here. Now remember, we want milliliters over hour, so we're going to need to set this up in a way that helps us get there. So 40 milliequivalents and 250 milliliters is our order, so it's going to go on the left. We're going to put 250 milliliters on top because we need milliliters on top. Pop our 40 milliequivalents down here. And then our recommended rate, or our policy rate, is going to be what we have available, and that's going to go on our right. We have 50 milliequivalents for 1 hour. Our milliequivalents crossed out. We're left with milliliters over hour, which is what we need. So now we can multiply across the top and the bottom. So 250 times 15 divided by 40. We're going to give us 94 milliliters an hour for our infusion rate. All right, so last topic that we're going to look at that we covered from this week is our infusions that have to do with medications that are dosed in units, so mainly insulin drips and heparin drips. In problem 6 here, our patient has an insulin drip going at a rate of 5 units per hour, and our solution has a concentration of 100 units and 100 milliliters. And we want to know what the rate's going to be in milliliters per hour. So draw our cross. Now our rate that our infusion is currently going at is going to act as our order. So it's going to go on the left. So 5 units over 1 hour. And then the provided solution is going to be what we have available. So our 100 milliliters over 100 units. Units cross out, and we're left with milliliters over hour, which is what we need. So you can multiply across the top and the bottom. So 5 times 100 divided by 100. We're going to end up with an answer of 5 milliliters an hour. All right, so now our last problem. Here, our patient has a heparin drip going at a rate of 25 milliliters an hour. Our solution has a concentration of 25,000 units of heparin in 500 milliliters, and we want to know what the infusion's going at in units per hour. So draw our cross again. Remember what our infusion's going at is our order, so that's going to go on the left. So 25 milliliters over 1 hour. And then our solution that we have available is going to go on our right. So we have 25,000 units over 500 milliliters. Milliliters cross out, and we're left with units over hour. So we can start multiplying across the top and the bottom. So now we have 25 times 25,000 divided by 500. And we're going to end up with a rate of 1,250 units per hour. Now some general important reminders about this week. All of your answers should be rounded to the nearest whole number. You should not have any answers that have decimals on them for this week's homework or on the test. And remember to review the IV infusion basics from the week 3 slides that are posted online. We're not going to go over those in a video. You can just review those on your own, but make sure you do review it because there will be questions on the test that covers that material. So if you have any questions, just let me know.